In this video, we're going to go over net ionic equations step by step and determine all the details by answering the following example question. So in a lab, you combine sodium chloride and silver nitrate and allow the reaction to proceed. After some time, you notice precipitate form near the top of the solution. What is the precipitate? Identify any spectator ions, write out the net ionic equation and the complete ionic equation. Now, the first thing I want you guys to do whenever you see a net ionic equation, I want you to remember that whenever we talk about net ionic equations, it involves some sort of a double displacement reaction. Now, remember that a double displacement reaction looks something like this. So we have AB plus CD, and then we get the products where the cations and anions switch, and we end up with AD plus CB. So what happened is that the A switched positions with the C, and the B switched positions with the D. So the cations and anions replace one another, and we get these two products. Here I've written it out more clearly. Now, what's the next step? Well, we know we have this double displacement reaction. Now we must utilize this basic double displacement reaction right over here and write out our actual reaction. So in our actual reaction, remember that it says that we have silver nitrate and sodium chloride, and we allow this to react. Well, sodium is represented as Na. So in order to do this question, you can either have a periodic table nearby, or you can simply remember that Na is sodium, and then our chloride is Cl. Now, sodium has a +1 charge, and chlorine has a -1 charge. So positive and negative cancel out, so we've written it correctly. Next, we have our silver nitrate. So Ag, silver has a charge of +1, nitrate has a silver has a charge of +1, and nitrate has a charge of -1. So those negative and +1 will cancel each other out, so we will simply get AgNO3. So we have sodium chloride and silver nitrate reacting. When they react in solution, remember it's going to be a double displacement reaction. So the two cations are going to replace one another, and the two anions are going to replace one another. So as a result, we're going to get sodium nitrate plus silver chloride. Okay? Here I've just written it out more clearly. So we have sodium chloride, silver nitrate, and they react to produce sodium nitrate and silver chloride. Now the next step that we have to do is label if all of these molecules are aqueous, liquid, or solid. So right off the hop, we know that NaCl, that's salt. Salt is soluble in water. So right off the hop, we can put AQ, meaning aqueous, which also means soluble. So sodium chloride is aqueous, so it's soluble. Next, we have silver nitrate. Now for silver nitrate, we have to think about our solubility rules. In our solubility rules, we know that silver is typically insoluble, and nitrate is soluble. So now the question is, if one of our cations or anions is soluble and the other is insoluble, how do we determine if it's soluble or insoluble? Well, if we have both an insoluble and soluble cation or anion, solubility trumps insolubility. So our silver nitrate is going to be soluble. So if it's soluble, once again, we're going to have AQ, because AQ represents soluble. So next we have sodium nitrate. Well, we know that this is soluble. Nitrate is soluble along with the sodium. Both of these are soluble cations and anions. My bad, I put S. It's AQ. It gets a little confusing because Kind of seems like S should be soluble, but S represents solid. So AQ is for soluble. Next up, we have silver chloride. Silver chloride, if we go back to our solubility rules, we know that silver is insoluble. So overall, this molecule is going to be solid. It's not going to be soluble. So we've labeled everything. This is very important. We have to know our solubility rules in order to write this out. And if you don't know your solubility rules, I would recommend to learn those first before moving on to net ionic equations. So sodium chloride aqueous, silver nitrate aqueous, sodium nitrate aqueous, and silver chloride solid. So we have 3 solubles and 1 insoluble. And here I've written out all of it clearly. Now the next step is to separate all of the soluble anions and soluble molecules into their anions and cations. Because remember, this reaction is going to be occurring in some sort of a solvent, for example, water. And if it's aqueous or soluble, it's going to dissociate into its ions. Remember, if something is aqueous, it's going to dissociate into its ions. Now when sodium chloride dissociates into its ions, we get Na plus and Cl minus. Then for silver nitrate, we're going to get Ag plus and NO3 minus. And then on the other side of the reaction, we also have aqueous sodium, and we have aqueous nitrate. Now, since the silver nitrate is a solid, it will not dissociate into its ions, so it will stay as AgCl, solid. So, what did we do? We essentially labeled, we dissociated these molecules into their cations and anions because they're aqueous, they will dissociate, and we labeled all of their charges. One important thing I want to mention is that before you separate everything into its cations and anions, you always have to remember that you must balance your equation. In this case, the equation was already balanced, so we were good to go. So balance your equation, then dissociate everything into its anions and cations. So here I've just written it out more clearly. So once we've written out everything into its cations and anions, once again, we're going to label what's aqueous and what's solid or what's liquid. So remember that whatever was aqueous in the molecule state, it's going to be aqueous when it goes into its anions and cations. So our sodium is going to be aqueous, our chloride is going to be aqueous, silver is aqueous, nitrate is aqueous, sodium is aqueous, nitrate is aqueous, but this is the silver chloride is solid because remember, it's solid over here and it doesn't dissociate into its ions, it's still a solid, whereas everything else is aqueous. So here we can see clearly that we've labeled what's aqueous and what is solid. Now the next step is that we are going to cancel out things that are similar on opposite sides of the arrow. So if this is our arrow, we can see that we have sodium on each side, so we cancel out our sodiums. Next, we have nitrate on each side, so we cancel out our nitrates. What are we left with? We're left with chloride, aqueous, we're left with silver, positive, aqueous, which react to produce silver chloride, which is a solid. Okay? So what did we do? We canceled out things that were similar on opposite sides of the arrow. That's really important. And then we brought down whatever was left over and didn't get canceled. So here we can see this written out more clearly. Now let's define what each of these things are. So remember, this over here is the basic double displacement reaction equation, where we can just understand that the cations and anions are exchanged between the two molecules. Next, we wrote out our equation from the information we were given. So sodium chloride right over here, silver nitrate right over here. They react to perform a double displacement reaction where we get these two products. Then we label what's aqueous, liquid, or solid, keeping in mind our solubility rules. Then we take everything that's aqueous and we dissociate it into its cations and anions, because anything that's aqueous means that it's soluble, and if it's soluble, it's going to dissociate into its ions. After that, we labeled everything that was aqueous or solid in our dissociated ions state. And then we canceled out things that were the same on opposite sides of the arrow. And then we brought down whatever was left over to get this equation over here. Now over here we can see that our chemical equation was the overall equation of the double displacement reaction. Our complete ionic equation was when we dissociated everything into its ions and cations and labeled the aqueous and solid and liquid state of each. Our net ionic equation involves what was left over when we cancel everything out in our last step. So the precipitate that forms is the silver chloride. Remember, because silver chloride was not aqueous, it's solid. And if it's solid, it's not going to dissociate and dissolve into the solvent. It's going to remain as a precipitate. So whatever is solid, that's the precipitate that you get. And in this question, it was the silver chloride. And then the spectator ions is whatever was crossed out in our last step. Remember, in the last step, we cancel out what's the same on opposite sides of the arrows, and we canceled out sodium and nitrate. Sodium and nitrate are the spectator ions because they do not take part in our net ionic equation. And that is essentially how you go about a net ionic equation problem. You always first write out your basic double displacement reaction question, write out your chemical equation, then label what's aqueous and solid or liquid. That's the most important step, because once you label what's aqueous or solid, then you can figure out what's going to dissociate into its anions and cations, and whatever does not dissociate because it's a solid will be your precipitate. Your net ionic equation essentially contains everything needed to form the precipitate, and the spectator ions are everything that are not involved in forming your precipitate.